Good evening, everybody. Welcome to BCS. Nice full room. We're on a subject called autonomous vehicle, and we've had some great news lately about that. So just to let you know, this is a group, well, multiple group event with BCS ELITE, BCS London, and BCS Entrepreneurs. If you want to talk to any of the groups, the chair is over here, Simon, please raise your hand. And then we have the events at the back. Phil Crew, where is he? I'm here. Okay, so Phil Crew's over there, that's BCS ELITE. I'm in all three committees today, and I'm also chair of BCS Entrepreneurs. So, health and safety first. There are no planned fire or fire alarms or anything. You hear the bell and leave slowly and follow the green sign. So it's actually outside this door, turn right or turn left. And the designated space is Exeter Street, which is the back end of BCS. So this is the agenda for today. I'm going to give you 2 minutes of my time to talk about what we're doing here today. I have the honour of having Ajit, who's going to be talking about the overall industry and challenges around autonomous vehicles. And our speakers, Claudio, Max, Grahame and Charlie, will take us through the whole autonomous vehicle landscape. If you've got questions, please write them down and keep them. We have a panel session. And then we go for some more refreshments. Alcoholic this time, and networking. So what does BCS do? Who are BCS? We're really a tech society, and the kind of goals of the organisation is to support students, tech specialists and corporations. As part of BCS Entrepreneurs, we're now supporting tech startups. If you're a tech startup or want to learn more, and we've run a number of events. So this is a thought leadership event, so it's about looking at what's happening in our world tomorrow. So, yeah, clearly business is upside down. You know, with technology coming up left, right, every building in the window. And what's not clear is our challenges. How are we going to address it? What's going to look like in the future? So we don't have all the answers, and that's why we've got these speakers. And if anybody wants to ask questions about what BCS does, please do. So the upcoming events, the next event is running a thing called TMA Taiwan. We're launching it. It's about an IP bridge between Taiwan and the UK. You're all welcome to come along. Thank you very much. And this is our speaker, Ajit.
So, good evening, everybody, and thank you, Shakib and BCS, for inviting me. So, my name is Ajit Jaokar. I'm going to be the chair for this evening today. I wear a few hats. The most most well-known being I am the course director of a course called Data Science for Internet of Things at Oxford University, which is exactly as the name suggests. It is AI and machine learning for IoT data sets, which include time series, deep learning, that kind of stuff. We work with Google, Microsoft, NVIDIA, Intel, just about everybody. And it's a pretty pioneering course in terms of what we do. So I have a pretty good kind of understanding of how these things fit together, purely from an AI or data science point of view. In my day life, I'm mostly working with the same thing, mostly at the moment with bioinformatics, so molecular drug discovery, genomics, and stuff. So if you kind of looking at the news from Uber, who's seen the video? Anybody seen the video? And it's actually very shocking. And the most shocking thing about it is, I think that in a normal accident, if you were to encounter somebody like that, you would slow down. But this car doesn't slow down, because that was one of the observations they made, because it does not recognize there is anybody there. And therefore it continues at its same pace. So if you were driving a car and somebody suddenly darted in front of you, even if it were an animal, you would press the brakes, but this, nothing like this happened. So this literally went through this moment. So what do we think about this in terms of a kind of wider perspective? So if you think about the idea that is technology here, I mean, are the sensors there? Could the sensors have detected this idea, this concept that somebody was coming very slowly from the side and then literally almost was in collision zone? Would that be better than humans? What is the policy? What is Uber's policy on this? what is the state's policy, because the state is Arizona, and Arizona as a state is very bullish on self-driving cars. When Uber, San Francisco kicked out Uber, they went to Arizona. So, I mean, every state is doing something different in this way, and then policy kind of plays in the whole game, and so does ethics as well. I mean, these things are not discounted. So, if we look at those four themes, technology, policy, ethics, and the business principles behind it, that's really kind of sums up what we will talk about today. So I won't actually introduce the speakers. I will then we will start off with Claudio and go through, and then we will have a panel discussion afterwards. So hopefully you will, if you keep your questions for the panel, and I will moderate the panel along with Shakib who is in the back, and will be hopefully an insight. Thank you. Welcome to Claudio. Thanks.
Hello, I'm a data scientist at knowthehighstreet.com.
We will take questions afterwards. We'll continue with the speakers. Yeah.
Cool. Hi everyone, pleasure to be here. My name is Max. I'm a CEO and co-founder of Selectica. Selectica is a startup from Germany actually. We're 50 people, also working on autonomous vehicles and especially looking into future supercomputers. The previous speaker already mentioned it. It's all about software at the end of the day. Sensors and all of that is somewhat covered. But to us, the key problem going forward is software running on those future superclusters or supercomputers. And I want to dive a little bit into the problem and why it's so difficult and why to us nobody really has solved it yet. Even though sometimes marketing wants you to believe self-driving cars are solved just because you see some Google or Uber cars, and we believe we're far from it. This is going to be somewhat technical, so I already apologized before I even started. I'm going to try to do my best. Actually, this how to handle the future compute capabilities or the future compute needs. It's not a very specific problem to autonomous vehicles actually. We see a couple of other examples as well. So 5G, which is the new wireless communication standard, it's supposed to be there in 2023. AI, VR, you hear all about those VR goggles and so on. But of course, self-driving cars is also a perfect example. And all of them have actually two things in common. One is, sometimes you think it's already ready and it's going to be there soon, and it's actually quite far away. The other one is going to be driven by extremely intelligent application. A lot of very sophisticated algorithms, which just means you need very, very powerful machines, right? Those next generation computing or edge computing or fog computing or supercomputers or whatever you want to call it, system of systems. At the end, it's always the same. You need very big, powerful machines running in those systems, and that creates a lot of problems. I'm not going to go down, too much history lane. I mean, it used to be, very simple. You had one single processor, which was your computer, and that one just got faster and faster and faster, right? That single core. At one point, that wouldn't get faster anymore. So industry being smart, of course, they need a new marketing message. So they just added, they didn't make one faster, but just added several ones. They added it up so they could pretend it still gets faster and faster, right? Of course, that doesn't make sense because software now, I'll get into those problems why that doesn't make sense. But from a hardware point of view, of course, that's the obvious way to solve it. And then, lately, computing anywhere, you're talking about very specialized heterogeneous computing, meaning for a very specific task, you have a very specific processor, right? For example, this localization and mapping at the same time, that's a very specific algorithm running on a very specific core. Of course, that processor core has nothing to do with the chip inside your mobile phone, and it has nothing to do with the chip in your laptop, right? Those are all very specific computes. What is interesting now that the question is not, which one of those do I need? Do I need an FPGA or a GPU or an ARM core? No, you're going to need a mixture of all of them, and that's exactly what I mean with future supercomputers or heterogeneous supercomputers. Heterogeneous meaning you're going to have different islands of different clusters of like multi-core, lots of ARMs, right? Somewhat general purpose processors. You're going to have FPGAs, you're going to have GPUs, right, doing surround view of your car, but also the 3D landscape in your cockpit, that's also going to be GPU. What exactly those technologies are, it doesn't really matter at this point in time. Just, there's going to be a lot of different islands on such a supercomputer, right? And that creates a lot of problems, and one of the key problems going forward. Life was pretty simple. You had one single application, you have a single processor, that's a one-to-one mapping. There's a tool called compiler, you press the button and you're done. And I'm exaggerating, obviously, to make a point, but compared to now, it was pretty simple. If you look into where we're now, you not have this single application. You still have a single application, but this is in a way parallel, right? Look at those, lots of different bubbles. And now you need to map those different bubbles to different processor cores, right? One example from one of our base station customers, you think a base station where your mobile phone connects to is probably the most boring thing in the world, but it's actually really, really complicated. So in that example, you're talking about 50,000 bubbles at the top, trying to distribute that to 1,000 different cores. Okay, so that's a really complicated software distribution problem. People are solving that today using Microsoft Excel, lots of crazy tables and weird charts, and you don't believe what I'm seeing. What we get from our customers, it's ridiculous, really. And it doesn't really work. It somewhat works, and that's why you have some dropped calls, because usually it actually doesn't work, right? So that's a typical problem. And now imagine the problems going forward. You not have one of those applications, but you have several applications. Those are exactly, the previous speaker talked about, localization and path planning. You need a world model, and you need to control your actuators. So you're going to have a lot of different applications running on a lot of different clusters, but those clusters are not isolated from each other, but it's one supercomputer, right? And of course, there's a lot of communication going on in that platform. So how to predict that communication, how to decide what to put where, that's exactly one of the key problems. And it's even more complicated than that, because there's not one programming language, and that's how I write my algorithm, and there's like several types of processors, and I need to map that. No, there are like millions of different ways on how to write an algorithm and how to bring an algorithm from algorithmic design to implementation, to actually bringing it, really having it running efficiently and cost effective on a given processor. So I'm not going to go into any details. Point here is just, there are a lot of different ways of writing that localization algorithm or that path planning algorithm. So what we're doing, as a company, allow me, one slide on that, because there are so many different ways of writing a software. And because Excel is not going to do it anymore, right? Because basically in Excel you have some kind of model and you're trying to optimize that model. And our point is, with complex software going forward, there's no way in hell you're creating those models automatically, manually, right? There's no way you're going to create an Excel table representing your application and then trying to optimize that Excel sheet. So what we're doing, we automatically understand your software. Right? We automatically built an application model, and we're using compiler technology. What that is doesn't matter at this point. It's automated. That's the key thing, right? Because if it's not automated, and you have software with 10 million lines of code, there's no way you're gonna have a representative Excel sheets for your 10 million lines of code, right? It's just not gonna work. But if you're able to build such a model automatically, right, an application graph or a graph representing your application. Well, now I can automatically optimize them. If I just have a graph, there are a lot of smart graph scientists and there's a lot of graph theory, and I can tell you what to put where, I can optimize it, I can do that for different hardwares. I can predict how the same algorithm runs on all the different hardwares I just mentioned before. I can even change the code automatically. I can distribute code. I can even tell you exactly which platform out of the 250 options, I can tell you automatically which platform you actually need. Not based on some marketing number, oh, I have 250 million trillion operations on the new NVIDIA platform. No, but actually specific to your given problem, to your given algorithm. Right? So what we're trying to do there, that shouldn't be any surprise. To us, it's the most natural thing and happens over and over again. If that was, going from assembler to C, right, that was one level of innovation, and that's, C compiler. But also in other industries, right? Electronic design automation. People used to do hardware, drawing lines by hand. At one point, it just got too complex, so the EDA industry started, and people use software to do the chips, right? Or in the CAD market, right? And that's how Autodesk became the market leader. At one point, complexity is always going to be so big that manual optimization is not going to work anymore. And we believe that's exactly where we are now for software design. So getting a little bit more specific, what does that mean for autonomous vehicles? What you see out there on the streets is, more prototype. Yes, it's surprisingly far and it works surprisingly good. And yes, again, I shouldn't say that, given the history from the last couple of days. But if you would open the trunk of those systems, that's how it looks like, right? And that might be okay for, I don't know, a robo-taxi or your fleet, right? But where to put your luggage in that robo-cab, bring you to the airport? Well, it's full with computer systems. And the reason being is all the problems I just mentioned, they haven't really solved. What they're doing is they have one algorithm running on one big Intel machine, the next algorithm running on the next Intel machine, right? So this kind of integration, lots of different applications running on the supercomputer in the middle of your car, not the trunk, but in literally the middle of your car, they haven't solved yet, right? And that's exactly the key challenge. How to go from this prototype, to serious production where your trunk is free again, and it's an actual car and not some driving around crazy supercomputer. And in order to get there, a lot of things actually have to change. First, companies, car manufacturers, they have to change. Right now, they have very isolated teams. They have an algorithmic team, thinking about traction control or path planning, and you probably use MATLAB to do that. And they throw it over the fence to some other group who needs to, okay, now make it work on a given platform. And that given platform was ordered by purchasing department 5 years earlier, and surprise, that software and that hardware has nothing to do with each other and it doesn't fit, right? What happens if it doesn't fit? You shoot it back to the algorithmic developer, fix your algorithm, it doesn't work. Oh no, you're just a stupid implementer, you don't know how to use the platform, you fix it, and boom, 6 months, lost and project lost or starting again. So, we believe this, what I mentioned before, analyzing the code, giving based on data, making those hardware decisions and optimization decisions, that's urgently needed. But if you now have not only one application running on one platform, but you have a lot of different applications running on the same platform, people, also have to start talking to each other, cross-platform, cross-team, right? Because again, all those applications are going to run on the same computer, they're going to use the same resources, and you're going to have contention, right? You're going to have contention in your communication architecture. So if this one team says, I did a perfect job, and the other team said, I did a perfect job as well, and now you try to integrate that on the same platform, and it doesn't work, what do? Whose fault is it, right? I'm sure you can think of the answer if I go back to one team, no, I did a perfect job, I'm done. You do the same thing with the other team, so what do, right? And that's going to be this core problem going forward. People need to start talking to the other software teams, hardware teams, but also across all the different functional teams, right? And just one example here, and you mentioned it already before. How would a typical flow look like? And that's actually much more complicated. But you have your LiDAR and your radar, all your sensor stuff, which you need fast I/O. Do I have a mouse pointer? No. Right. So the sensor data might come in here, and you're doing some pre-processing. And that's going to go to your deep learning accelerator. So here I'm going to recognize, oh, that's a woman, and that's a person, and that's a tree, and so on, right? At the same time, the GPU is going to do 360-degree, surround view. That's also going to come here. And now this guy is going to send all his data over here. Now I'm going to, do localization and mapping and path planning, right? And at one point, it's going to go to your safety MPSOC where you actually say, okay, now go left and now go right, and those kind of decisions, right? So even though those are all separated applications running on separate clusters, at the end, they all communicate through that red bar here, right? Which is the shared communication architecture, and that's going to be the key challenge, right? How do I use it? What do I do if I have contention? How can I make sure that design actually works, right? That's going to be the key going forward. And what is interesting, this is actually very realistic. That's basically the Audi A8. So that's the first level 3 car. It's done, but it's not certified yet. So it's not allowed to run as a level 3 car, at least on German highways. So if that's already so complicated, and that's just a level 3 car, imagine what that means for a level 4 and a level 5 car, right? So for level 5 cars, you probably need 10 of those. But of course, the connection between a platform like this to the next platform, that's going to be slower than this connection on the chip, right? So now the problem, right, you have not just clusters on a system, but you have a system of a system with clusters inside, right? And hopefully that, makes it a little bit clear why the complexity, we're not even at the end of that complexity is just starting if that's just a level 3 car, right? So what we're doing, doesn't matter for now, just, trying to do the software optimization as well as the software integration. So a lot of, technology to automate some of those problems. And the key thing going forward is the system simulation at the end of the day, right? Because that system simulation is bringing everything together. Multiple applications on multiple systems, right? Just 3 more, screenshots. Hopefully that helps to visualize a little bit, right? If our software, looks at your self-driving car software, okay, you get a lot of, insights. How does my software behave? You can say, okay, now please optimize the whole thing for performance, or please optimize the whole thing for power, right? And that's another interesting point. Depending on which domain you are, you want to actually optimize for different stuff, right? Our base station customers, they want to optimize for peak power because at the end, that's the power bill they have to pay to the cities, right? For autonomous cars, it's actually average power you want to optimize for because that's the heat being extracted from the chip, and people are talking about water cooling in the car for level 5 cars just because the whole thing gets so hot, right? It sounds ridiculous, water cooling in a car, right? But that's what people are discussing. And then what we can do is say, okay, this application, run it on a given platform. That platform is very heterogeneous, lots of different colors, so it looks colorful. But we can not only tell you what part of the software to put on the different clusters, I can also predict the full execution on a given platform, and that's what you see here, gun charts, pass dates, communication link, utilization. So even though I've never touched that hardware, I can give you full insights into that execution. And of course I can do it with one hardware, but I can also do it with my 10 other choices, right? Hopefully saving a lot of time. But also, predicting where would I end up in 6 months and not putting 2,000 engineers on it manually, and then after 6 months realizing, oh, that was the wrong platform, and I start again from scratch. Yeah, so our key goal is help those products from concept to mainstream, and the key problem there is the compute power, which is not available yet or is not utilized yet. And that's, to our belief, that's going to be the key issue forward for autonomous vehicles. Thanks.
What do you want, the aircon or the lower? Yes, it's a small panel. Oh, right. Yes. Oh, I see what it is. That's fine.
Oh, right, of course.
Okay.
Thank you.
I can turn it off, but then I can turn it off, and everybody's going to get off.
We need water cooling.
It's probably cold.
Oh, I see what. Are we there yet? Oh, you're on there, okay. So maybe in that case, I didn't realize that it was taking much longer. Maybe we can take a couple of questions. Have you got? Oh, you have? Yeah, okay. So I will take a couple of questions if you for the first two speakers until we get the slide. Yes, sir. Yeah. Please introduce yourself briefly and who is ready to.
Okay, I'm Jonathan Save. I'm a lawyer at the Insurance Institute. I just wanted to talk about the software implementation side of things, because in other applications like financial programming, for example, bespoke silicon seems to be the way to go rather than software. You change the architecture of the computation, and so we would use, for example, moving averages rather than CAPM models, things like that. And I guess the point being that the system, as it interacts with itself, has a sort of self-organizing character. And there are some things that don't need to be controlled in the design. And I was wondering whether that's where the complexity theory stuff was playing in the part. Actually, it was a question.
Let's go first.
Because I'm just thinking about the emergent behavior systems. I mean, some bits a lot faster.
To answer that probably takes a day, right? I think there are several aspects to it. One, everything is moving in software, right? And I'll get to the hardware side in a second. There's software-defined radio, software-defined virtualization, software-defined reconfiguration of hardware, right? So there's a lot of software stuff going on.
Except financial trading, right? Where latency control is the key, so it's good for that.
Yes, they're reconfigurable architectures which are used in that kind of stuff. I mean, if you don't have software, if you don't have a part of software needed, I mean, all of that doesn't apply, obviously, right? But I think going forward, and Xilinx had a huge announcement last week, actually, where they want to combine software running on reconfigurable hardware. I forgot what they called it. So adaptive reconfigurable hardware enabled by software. So there you'll try like, okay, I can do whatever I want in software. I can even reconfigure the hardware at runtime, always having the best trade-off of performance versus power versus cost, all at the same time. But yeah, good luck finding out where those switching points are, like when you want to switch the hardware or the software. I don't know if that helps in any way, but.
Okay, we'll take one more question until I hear otherwise. Is that okay? So, yes, sir, yeah.
Sorry, I haven't heard the first guy probably. I know we talk about autonomous cars, which seems maybe they're self-contained, but how important is it that actually cars talk to other things, other cars, etc., as a system? So why do you think, how important part of the system is it that they actually communicate with other cars and other entities?
Oh, okay. Yeah. Okay. So this is like ties back to the what is called smart cities. So that can be very important in the sense that a truly fully autonomous car doesn't need an infrastructure to in the city to drive or safely and autonomously. However, you might run into optimization issues. Like, so, for example, if you wanted to optimize things like traffic congestions or pollution, then cars need to know where other cars are, and that is pretty much the only way you can reliably solve that problem. There is so much that you can do by just installing everything on the car and then hope for the best. Like if you think about it, so for example, if you have an intersection or if you are aware where other cars are in the neighborhood or like where traffic is, then you can make smart choices about how to direct cars. And then there are like other people who say, well, potentially in order to have autonomous cars earlier, you might start installing sensors along the road to like help cars localize themselves and so on. Personally, I'm not particularly excited by that solution, and not just because it's technically less exciting, it's also because you need to modify the entire city infrastructure that might not be feasible, but like what could be more feasible is to make sure that cars communicate.
Yeah, I'll add a little bit to this just briefly before we hand over to there is a trial going on in Oxford. I think it is with, I'm not sure with this Oxford, but a couple of people are. The idea is that for ambulances, you want to speed up ambulances. And at the moment, of course, it is not talking to other cars. There are no other cars from at this point. But that's the concept, and it ultimately goes forward. So at the moment, what it is doing is optimizing the traffic lights. So Siemens and I forget another company, they run the traffic lights. So the ambulance essentially coordinates that. But the idea is it works. So I see use cases like that, where you start that. Okay, very good. So I should now hand over to you.
Thank you very much. Good evening, everybody. My name's Grahame Bennett. I head up the fleet engineering team for Royal Mail. So we have a huge range of vehicles, which I'll come on to in a minute with a little bit of a breakdown. I run a small team of engineers, and the reason you'll see a British gas vehicle on the slides is actually because we've just opened our service workshops to maintain vehicles from external fleets. So not only do we maintain and look after our own vehicles, we look after external clients now. And a huge range of vehicles, from the small Alligator John Deere type vehicle that you'll see in the Highlands and Islands of Scotland to 44-tonne double-deck trailers that goes up and down the motorway, and everything in between. The vehicle in the top right-hand corner there is actually a concept vehicle. We're working with a company called Arrival, and we took delivery of our first electric truck back in August. We're due to be running around 9 of those trucks, and that's the concept vehicle that we'll get later in the year, hopefully. But I'll talk about some of the issues we face with electric vehicles. So even before we get to autonomous vehicles, some of the problems that we see, and actually probably bring something back down to earth with the real-life operation of a fleet of that size. So the size of our fleet at Christmas was 52,920 vehicles there. That's at Christmas, so that included a number of hire vehicles, and you'll see the range of vehicles from compact vans all the way through to the 44-tonne vehicles. The fleet averages around 48,000 for most of the year, but a big scale there. The reason it's grown in the way that it has is because you no longer see a postman on a bike. We changed our delivery methods based upon what we actually deliver every day, and we took the weight off of our post people's back from a safety point of view. So what we do now in a number of our vehicles is actually in the car-derived vans, we actually use those as the delivery point, and two people will work from a van and move the van on. That in itself brings challenges, because if you look at the technology on vehicles now, diesel particulate filters to make the vehicle cleaner do clog up if they don't generate enough heat. We've actually bought 1,000 petrol vehicles. We've just recently bought 100 electric vehicles. So we're on a journey, but we have to manage that. Some of our vehicles probably do 3 or 4 miles a day in city centres. So how do you then get the benefit back from an electric vehicle when you've invested what's double the price of a conventional vehicle? In terms of what we move, so we base our vehicle fleets on the large side in terms of York containers. Nothing special about a York container other than it was developed and trialled in York, and that's why it's called what it is. We use sleeved Yorks for parcels, and what you see in the right-hand column there is we're actually in the business of managing the decline in letter volumes and magazines that we used to move and actually had a lot of weight to now volumetric issues with the internet and parcels. And that's having an effect on our fleet. The problem we have as an engineering team is actually the vehicle that we buy today we'll still have in 7 years' time. The truck that we buy today will still be there in 10 years' time. And I guess my challenge to all of this is actually managing that transition as you move forward with different technologies. We have to meet the universal service obligation, so we have no choice. We have to deliver the letters. Our competitors don't have to do that, so they don't work under those parameters. So when we have a failure, albeit whether that's a vehicle or that's a failure in a mail centre, there is an obligation on us to deliver and find a way. So when we move forward with technology, we've got to be pretty sure that it's going to work for us. And my question around autonomous vehicles is actually how close we'll get to that and what's the reliability built into that. We're actually working on lots of things and huge issues around clean air zones, as you're well aware. What we've done in the past as a business that has to come into London is we've made sure that all of our newer vehicles come into London. We can't do that anymore because actually with that fleet across the whole of the UK, we can't just move the cleanest vehicles into London because everybody else is now following what the Mayor's doing. And quite rightly so, but it makes it very difficult. As I said, our vehicles last for 7 years or 10 years. So the vehicle we buy today, what does that mean in terms of what will be the parameters and what will be the level? Euro 6 is currently the level that we operate at. But will that still be there in 7 years' time? The Mayor have moved that on, and he's already quoted that by 2040 everything should be electric. My question there is around the infrastructure, and we'll come on to that as we move through the slides. So there's a number of things there that we have to keep an eye on and look at as an engineering team when we're dealing with our fleet. We currently take vans, and if you see there, that's what we do with a van. So we sort all this mail, we prepare it all. The postman or postwoman takes it out to the van, they place it in the van, or two of them do, they share a van. By the time they get to where they're going, what does that actually look like? And so actually we need to look at whether we're using vans or whether we do something different. And in the bottom there we just see a chassis cab that we're developing that actually has better use than a conventional van. It adds price, but actually it's about how we rearrange that and get the best efficiency from our routes. This starts to get interesting then when we talk about electric vehicles. There's lots of electric cars out there, there's lots of competitors, but when you move into the truck world, there aren't many that are actually in that marketplace. There's lots of people that convert vehicles. We had a conversation with a company that converts a Fiat Ducato. They buy the Ducato in Turin, they drive it to Turkey, they strip out all the diesel technology, they install electric technology, and then they come in to sell it to us. When we asked the price, it wasn't a very long conversation, as you might imagine. We've been working with a company called Arrival. They were formerly Charge Automotive. I don't know how many people are aware of this company, but they're actually disrupting the marketplace. They're throwing a number of challenges to the big manufacturers. We were involved in a trial. We're fortunate enough we picked this one up and said, yes, we'd like to run with this, and we're going to get 9 vehicles eventually. I'd like to have said that we've got all 9 now. The original timescales were that we would have 9 trucks in place in Mount Pleasant. We're actually working with 1 at the moment, with 2 more in build. The reason we're only at 1 is because actually when you come to a truck that you've built from the ground up, you're not taking a DAF truck and converting it, you're building something from the ground up. There's a challenge. We took it in August, and I think the first issue that we had happened to be the hottest day of the year, and one of the motors overheated of an electric vehicle. 3 weeks ago, I think in the cold weather, we couldn't disconnect it from the charging system because the batteries are telling the charging system that they weren't fully charged. They wouldn't release the cable because the cold weather had affected the batteries. When we talk about autonomous vehicles and then the diagnostics of that, I just need to add that to all of the simple things. What is relatively simple, my challenge is actually my technicians now that work in our workshops and we do our own maintenance, 900 of them, faced with diagnostics and diagnostic tools for every different manufacturer using a different system. Whether it be a DAF vehicle needs a £15,000 diagnostic tool, or a Mercedes, or a Fiat. And then you add on autonomous vehicles on the top of that. There's a huge challenge for those technicians to be able to maintain those vehicles. So, where are we with this electric vehicle? Actually, the reason there's a picture of a phone up there is when you give a driver that's used to driving a truck around London, a 6-speed truck in London, that's quite a challenge. That's quite a tiring day. You give him an electric vehicle, and the first time we did this with a prototype, he drove it around the yard, jumped out of the vehicle and said, "Can I have one tomorrow?" The tablet, go from switch onto an icon, switch the vehicle on, it's basically like having an iPad in the vehicle, press drive, and it comes, press the icon, park, reverse, neutral, and drive. Slide 3 fingers down, you're into drive, and off you go. Take your foot off the accelerator, and actually if you can read the road ahead, you take your foot off the accelerator, the vehicle will self-generate its braking, and you don't need to touch the brakes. So when you get used to that, and that can be set for driving styles, you take your foot off the brake, and actually you only use the brakes in emergency. Driving around London, who would complain about that? But we are learning from it. One of the things with the tablet is when it's a sunny day, they can't see it, and actually sometimes it freezes. So when you're on a hill trying to get into reverse, and the tablet's frozen, and there is no handbrake because of the system that's built into the vehicle, it's done automatically, there's a kind of a learning curve for the driver. Now if it's autonomous, we haven't got that learning curve, but somebody's still sitting in that vehicle for the autonomous part to kick in and do that. So we're learning, and so is the company. Software, it's great that actually some of the things that happen with the vehicle, the factory tells us, so they're connected to the vehicle, and they're making software changes that we're not even aware of. They'll give me a call the following day and say, "Oh, last night we downloaded something to the vehicle." And the challenge when we were talking to them about autonomous vehicles, because they're in that place, and we'll come on to that in a minute, was actually about when there is an incident. I'll go back to California when the vehicle trial, there was a white truck that was next to the vehicle, I don't know if you recall it, and the driver was killed. It was autonomous. The software to stop that happening again was downloaded to those vehicles within a number of hours. If I'm the driver and I've done that, what's to stop you as a driver doing that again tomorrow? So the question about the safety, once the solution's there, can be downloaded to the vehicle. So you'll get the event, unfortunately, but actually you can then, once you've worked that system through, you don't need to bring the vehicle in. Normally on anything like that, if you had a problem with your braking system, you'll get a letter from the manufacturer to say bring the vehicle in. You may well do that, you may not. You may pass that vehicle on and actually they never catch up with the owner, but when you've got an autonomous vehicle and that sort of system, you can download it. So the driver feedback's been really good. Autonomous vehicles we come on to. We've also bought 100 electric Peugeot partners, and again the feedback from the drivers is really good. We're in conversations with Ford. We'll be trialling a Ford Transit electric vehicle, LDV. We're also looking with those. Why is a black cab in the right-hand corner there? Anyone who buys a black cab, any cabbie that buys a black cab on the 1st of January of this year, it has to be electric. The factory no longer produces diesel vehicles, so they've got their big factory up in Coventry. I was fortunate enough to go along and talk to the guys there. They contacted us about, if we were to develop a van, what would that look like? They're owned by a Chinese company, but they own Volvo. And a lot of the technology they were drawing was drawing down from Volvo. When we talked to them actually about what would a van look like, when you look at what a cab does and what we do as Royal Mail, we make a lot of stop-starts, obviously, in what we do. Some of our vehicles could open the door 100 times, put the handbrake on 100 times, turn the ignition 100 times. A cab driver, with people getting in and out of his cab, one of our biggest issues is the hinges on the doors. A cab actually is built for that. And actually, if they turned it into a van, what would that look like for us? So we're actually working with those. They will be building a van that will be involved in the trials with later on. So that's why the black cab's there, if anyone was unsure. So we get on to autonomous vehicles. Arrival, the company that built the electric truck that we're working with, when I went to see it as the first build of the prototype, that dev bot was on the other side of the warehouse. So it's a reasonably small warehouse at the time. They've since moved into a factory, which will be, and I don't know if anybody's seen anything from Arrival. Their claim is that they will build a truck in 4 hours with a robot and a technician working together. It won't be the conventional production line. But when we went to look at the first vehicle and while it was in build, on the right-hand side was our truck being built, and on the left-hand side the two of the dev bots. So that's a Jetta sports car, capable of taking a human being, but actually built as an autonomous vehicle. They're connected with their electric vehicles to Formula E, so the race series Formula E. Their trucks are used for the driver's parade. You wouldn't want to put a diesel vehicle in amongst electric vehicles when you're talking about that type of circuit. But these were tested. So the first test was done in Buenos Aires. One of the dev bots, so the team develops the software. So all the cars are the same. It's how you develop the software and make that car go around the track that produces the winner or not. One of the cars had an altercation on one of the corners in the Buenos Aires, before the Buenos Aires Formula E event, so they were testing these and showing the crowd. I guess it could only happen, I can't see it happening at Silverstone, but a dog ran onto the track. The dev bot spotted that and stopped until they cleared the track of the dog that had run on to applaud the vehicle or whatever it was doing. So quite interesting. When you see that, now what they've said to us is, what would that look like for you if we were to build you a truck that is autonomous ready, ahead of the legislation? So I think what guys are saying is there is that opportunity there. And the next one feeds onto Robo Race, which is also part of that series. So ultimately that's where they'll be, with a car that's faster than a Formula 1 car, that has no, because of electric power can be delivered straight away, there is no lag in the engine and the systems that work with that. But also if you've got a car that doesn't need a driver, you don't need to worry about G-forces, you don't need to worry about driver safety, and the aerodynamics are obviously better than they would be with a driver seat. So we started to think about what would an autonomous vehicle look like for us. And I'll just pick out, we were doing some training on the electric vehicle because we maintain our own vehicles. So we need to understand what we need to do to make that safe before we do the regular safety inspection on that type of truck to make sure that it's not going to be electric, we're not going to get anybody electrocuted. And during the discussion, I had some union colleagues with me who've taken those through that process and involving them. It's always better to do that at the start. And during the break, one of the guys from Arrival started to talk about the autonomous vehicle concept and would you be interested in your truck? And I thought, this is going to create some waves once they start to hear this. We're here to talk about maintaining an electric vehicle, and all of a sudden we're talking about autonomous vehicles. How's the union going to see that? The safety rep said that would be brilliant. You could have knocked me over with a feather at the time, but he then went on to say that our yards, and he's quite right, our yards are the unsafest place that we have in our business from a driver's point of view. We get dog attacks out on the walks, but in our business, within our own sites, the yard is obviously the most dangerous place. If the vehicle can come to the bay, once the driver signs on, the vehicle comes to the bay, he loads it and then drives out of the yard. We have no pedestrians in our yard. So actually, is that the place to start? And can we geofence our yard? And can we use that within our yard? Ahead of the legislation for the road. So why wouldn't you? And if you can start to think about that. What I haven't had anyone talk about yet is the price and cost. That's another issue, I guess. So from that point of view, we've looked at that. Our National Distribution Centre up in Daventry probably has 60% of the mail that goes through our network at night go through that site. Possibly more than that, I'm not sure of the exact figure. What happens in that yard on an average day, 700 or 800 trailer movements in and out of that yard. On a peak day, it would be closer to 1200, so Christmas time. There's an awful lot happening there. We use 14 shunter drivers on a 10-hour duty. there's a shortage of HGV drivers, but we've got 14 of them sitting in the yard. Could an autonomous tug shunt a vehicle, collect that trailer and take it to the bay? We put those 15 drivers back on the road until we've got autonomous trucks on the road. And actually we use a yard management system that tells the shunter which bay, which trailer it's on, which trailer in our yard needs to be taken to which bay. So it can tell the vehicle to do it. It's already telling the vehicle, it's just that the driver's doing it. So would that work for us? Yes, I think it would. It's about then how we tie the technology from the shunt vehicle to all our trailers. And the reason I say that is actually, as I said earlier, we've got trailers 14, 15 years old. So we buy a trailer tomorrow that perhaps is capable of doing that. What do we do with the rest of the fleet and the huge expense of converting that fleet? So this transition is a big issue. So that is probably where we're at. The other questions I have is then who does the vehicle check, who does the trailer check? What happens if that trailer's got a puncture? There's no autonomous vehicle going to tell me that. People will tell me about tyre pressure monitoring, etc., but actually it doesn't measure tread depth. So then we put a vehicle out that's loaded out onto the road, the driver picks it up at the gate, and it's got a ball time. Not insurmountable, but all things that need to be considered. And then when a vehicle breaks down on the road and it's an autonomous vehicle, I'm kind of in that space as to what happens then. Does this autonomous vehicle have somebody in it that hasn't got a driving licence? I don't know, not from our point of view, but actually where does that lead to? So they're the kind of questions I'm conjuring up in my head. Sorry to rain on the parade. So, DHL developing, I was fortunate enough to go to DHL, visit their site, and they bought the company. It's a bit like the Remington advert. We liked it so much we bought the company. So they bought Street Scooter, who are developing electric vehicles, and they interviewed about 150 of their drivers, took their feedback and developed their own vehicle rather than just buying something from the manufacturer. And there's very simple things in that where the seat squad, because drivers are in and out of the vehicle all the time, doesn't have the high squad on the side by the door. It sounds really simple, but actually they're the things that we get into in Royal Mail because of the way the vehicle's used. So they did a lot of work around that. They're now developing Follow Me. So the driver drives to the point and makes the parcel delivery while he's out making that delivery. What's the impact for most delivery drivers is actually not about where the delivery point is, but where to park. And actually how difficult is that? So if the vehicle goes off around the block while he's making that delivery and getting the sign for, or parks itself, he just tracks where that is. So they're developing a system called Follow Me that follows the driver along the route. I've got the levels there, and I kind of think we've discussed that already. I think previous people have, but I would have to say that even in some of those, what we experience on the trucks, and truck development moves quicker than it does in cars. So the assisted emergency braking systems were in trucks before they were in cars. We have, on a regular basis, drivers telling us that actually the dash lit up and the brakes came on in the truck for no reason. It's the middle of the night, there's nothing in front of it. This technology is not perfect. And then you get the issue with the driver then about why did that happen and is it safe to be in this? So when you've got something like that sort of designed as a safety concept to slow the truck down, should he not be paying enough attention and it doesn't avoid the collision, but it will certainly reduce the impact of the collision. When that system starts to come on of its own accord through, we've got to build up confidence around people hanging over their vehicle. And vehicle platooning, I'll just very quickly, that's already happening. It's going to be trialled in the UK. It's been trialled in Holland. All the manufacturers got together and actually done that. The trucks are ready to be able to do that. The question, I guess, is 12 trucks in a row going up the motorway. That's quite a length of vehicles. You want to get to that exit, and there's 12 trucks in the way. That's the issue. Do they use it at night and actually use the outside lane, which trucks can't do at the moment? So is there a legislation change that needs to happen to allow trucks to use the outside lane and people undertake? In the States, you've got exits on both sides of the road. So is the UK ready for that? But that technology is in the road now. Thank you. Thank you.
Very much. Right, I'll try and get this to work here. While we get the PowerPoint working, it's just been a natural progression. Claudio, very, very positive. Max beginning to say this is hard. Graham saying, actually, quite tough. I am the miserable Scotsman at the end that says this is actually bloody hard. So before I get on to autonomous vehicles, very quickly about myself. I'm a management consultant partner with PA, so I've never really had a proper job. I cut my teeth years and years ago developing code for the transport models in the UK, some of the biggest transport models. Wrote in a lovely language called Fortran, and after lots of time and effort managed to become a partner in PA. Many of you would see that as a downward progression, but I actually see it's an utterly amazing job. I get to work with some really, really interesting clients, address some of their most complex and difficult and challenging issues. Work with clients like Highways England, developing their 30-year strategy, with Trafikverket, who run the roads and railway network in Sweden, and the Roads and Transport Authority in Dubai. Also work with a number of fleet providers, many of whom are confidential, but currently helping the Ministry of Defence buy one of the biggest and most complex fleets around. So, not yet done any work for Royal Mail. They have a truly impressive fleet of around 50,000 vehicles, but we'll see. We'll see. Right. So what are we talking about? Let's try and get this to work. Try and get autonomous vehicles to work. Right, here we go. Are we ready for autonomous vehicles? Interesting title to the session. No one's challenged it as yet. Why should we be ready for autonomous vehicles? I would say autonomous vehicles need to be ready for us. This picture here is a picture we developed at PA to try and capture some of the complexity of the system. A lot of this evening's discussion has been around the technology and the computing power required for it. Grahame has started to touch upon some of the business issues. And if you look around this picture, and you can download it from our website, there's all sorts of issues around regulation, vehicle system design and production, insurance and liability. I think we've got a couple of insurers in here tonight, so I'll be interested to hear their views. We've got all the pre-journey type information. You were talking about pre-journey vehicle checks. Does the vehicle have stuff loaded correctly? Is it fit for purpose? Does it, are the sensors all clean? Normal interactions on a journey, then you have abnormal interactions. We can all operate wonderfully in California in the lovely sun, but can we operate on a road in England in, say, mid-March when there's a bit of snow on, you can't see the road, you can't see the white lines, can't see anything, think not. Then we have the end of vehicle life, what happens to the vehicle at the end of the life, in fact what actually happens after a year, because a lot of these sensors have to operate in quite challenging environments. It's not like a computer or laptop sitting in your office, it's taking it out into salt, wet, heat, cold, really difficult environment. And are we saying these vehicle sensors are going to continue to operate year after year? And how are we going to actually service those? It's great when you buy something and it works and it's got a warranty, but actually if you have to replace half the kit after a year, is that warranty still valid? And who's going to do that? And how does that relate to software updates? In fact, I disagree wholeheartedly. An autonomous vehicle cannot be autonomous until it's connected, because how on earth can you download patches? So you need a mechanism to communicate with a centre, you need a mechanism to communicate with other infrastructure. So there's all sorts of challenges there. I can't even get my phone to work on the Strand, so how are we going to work with mobile phones? Right. Some questions are easy to address. Can we make the technology work? And I actually think we probably can. In a few years' time, I think we will see some level 5 autonomous vehicles operating in restricted environments, whether that is at a depot, whether that's at airports, or whether that is operating a bus route on a predefined route. I think the technology is actually quite, you guys will sort it out, I have no problem with that. Ethical decisions, yeah, I've seen the MIT ethical decision, very interesting one. They did this test with students at MIT about the vehicle driving along the road, you see a pedestrian up ahead, the choice is, do you hit the pedestrian, or does the vehicle drive into a lamppost, killing the driver? So lots of people ask this question, 50-50, kill the pedestrian, keep the driver alive. It's actually very easy. If you're traveling in that car, if you choose to travel to get into that car, What are you going to choose? Am I safe in the vehicle? Yeah, of course. You're not going to buy a car that makes it profoundly unsafe for you. So a lot of these ethical questions actually disappear when you start bringing in who buys the car. If you get a situation of you've got, the other one they quote is two people crossing a road, and you've got to brake, you have to brake, but you're going to kill one person. Which one are you going to choose to kill? The one on the left or the one on the right? Actually, it's never a 50-50 choice in these decisions. The vehicle, our sensors, we've always got a perception at that time. So I don't think it's a black and white decision. I think computationally it's actually quite simple. You go on the information that's available. So I believe the ethical decisions are actually quite simple. Can we make the systems secure from cyber attack? Bloody well hope so. Financial systems seem to be reasonably secure. I would hope our phone system, our car systems can be, because if they can't, why are we having this conversation? Can we insure self-driving vehicles? I believe there's one or two insurers who already offer policies for insuring self-driving vehicles, even although they don't actually exist. And it's because insurers actually think differently. They think about liabilities and risks. I think a more interesting question is, what are you actually insuring? And who takes the liability on? So when you insure a driver, or in Europe you insure a vehicle, it's the risk associated with that individual. I think when you get into self-driving vehicles, the liability actually sits with the people who write the code, heavens, people who develop the hardware, heavens, and people who maintain the vehicle. Because if there's no one in the vehicle, who takes the liability? Can we regulate self-driving cars? Of course we can. It's not that hard. Government announced the other day a review on regulation of legislation around self-driving vehicles. And to show you how easy government thinks it is, they think this review is going to take 3 years. 3 years to review legislation. Put this into context, it will be a different government in 3 years' time. We might not be in Europe in 3 years' time. Everything will have changed. Those are the easy things. Black hat time. Some questions are much harder. Who wants them? Grahame over there has 50,000 vehicles. At the moment, he's not saying, I want them. I am not convinced there is a huge unmet demand for autonomous vehicles at the moment. If you have a lot of money and can afford one, you buy a supercar, or you buy a Bentley or a Rolls Royce. If you don't want to drive, you buy or employ a driver. If you can't afford a Bentley or a Rolls Royce, you get a taxi or a bus. I am not convinced in the UK there is a huge unmet demand for transport at the moment. This idea that there's vast numbers of people who cannot move around because they don't have access to a self-driving car. I think the manufacturers are developing a need for us that actually we don't want. Now, some manufacturers do that very well. Who'd have thought 20 years ago we all need an iPhone? But apparently we do. And if you're my children, you need the latest iPhone. So I think it's a really interesting question, really interesting technical challenge, but at the moment there's not a burning platform. The second, much harder question is, what's the business model? Who is going to own these vehicles? The picture that's painted out there is you'll get your phone, you'll call up an autonomous vehicle, and drive around your house. So you do need to have connectivity. So it'll drive around your house and pick you up. So who's actually going to own that vehicle? Will it be the leasing companies? So most leasing companies now own large numbers of traditional vehicles, and what they don't want to do is undermine their existing asset value by bringing in autonomous vehicles, thereby rendering their existing infrastructure worthless. So there's a huge number of people who have an interest in keeping the value of cars up, values of existing types of cars up. We currently have about 30 million vehicles in the UK. There are no self-driving vehicles being bought at the moment. The average turnover of the fleet is about 10%. So it's going to take 10 years before we get a reasonable number of autonomous vehicles, assuming that you could buy them tomorrow. I don't think that's going to happen. One of the other arguments is about our current fleet is vastly underused. The sort of factoid that's put out there by, let's say, people like Donald Trump is that 95% of the time your vehicle's left sitting on the driveway. So if we all had autonomous vehicles, we could reduce the number of vehicles on the road or being parked by a factor of 20. But if that's the case, the automotive industry is stuffed, because the number of vehicles being bought is reduced dramatically. So I just don't get the business model out there. So that touches upon the billion other cars out there, the legacy fleet. What about non-mechanical road users? The biggest challenge for me, this is about the hardest one, is what happens to pedestrians. And you were talking about Formula One. Actually, I think it was a pheasant that went onto Silverstone a couple of years ago, went into someone's vent and the car blew up. But what happens out there when a pedestrian wants to cross the road? Now, forget what happened in Arizona. We are being told that these vehicles will be ultra safe and no one will die, right? So 3,200 people die on average across the world every day. And one of the underlying sort of business case theories is that autonomous vehicles will stop people getting killed. That means when you walk in front of them, unlike in Arizona, they will stop. If that is the case, London will be gridlocked, because no one will wait at no, seriously, no one will wait at traffic lights. If you are a cyclist, you'll cut every single autonomous vehicle up. What happens when things go wrong? Slow time or real time? So let's talk about a real time situation. There's been an incident in central London. Police car needs to go from A to B, puts on its blues and twos, goes down the road. So autonomous vehicle, tootling along the road, middle of the road, and it sees a police car behind it. Are we going to give it the intelligence to know that that's a police car? When it sees a flashing blue light, it should pull into the side. Okay, we do that. Guess what? I go out in my car with a flashing blue light. No, says someone. I'll tell you what we do is we fit an RFID chip or some sort of chip into every single police car. Really? We're going to do that? We're worried about cyber attacks? That's not going to work. I remain unconvinced how, in real time, an autonomous vehicle is going to get out of the way of police, fire, ambulance, all emergency services in a controlled manner. We, as drivers, manage to do it quite well. Pedestrians do it quite well. Autonomous vehicles remain unconvinced. When things go wrong and a policeman says, "Sir, that road's blocked," what you'll need to do is turn around, drive up that one-way street, and then go up that way. I say, okay, fair enough. Autonomous vehicle arrives. The policeman said, there's no one in the car. The policeman says, what you need to do is go up that way. How does it contact the autonomous vehicle? In the wonderful world of connected infrastructure, that it's quite simple, I think. But who is going to be the central repository of all that information to allow vehicles to drive the wrong way up a one-way street when an incident happens? And actually, stuff like that happens the whole time. There are a huge number of incidents on the road, and if we get a few more autonomous vehicles on the road, there'll be a lot more incidents. The current evidence is that autonomous vehicles are safer, largely because they drive so slowly, absolute truth, so slowly, they reduce the capacity of our roads, right? So we as a bunch of road users, we as a society need to make a decision whether we're serious about safety or we're quite happy killing, in the UK, a couple of thousand people a year, whether that's an acceptable thing to do in a modern society. Will it deliver the benefits? Environmental. I'm not convinced of that, actually. People keep on saying autonomous vehicles will be environmentally much safer. Electric vehicles, will be environmentally a lot cleaner. Electric vehicles will do that. I'm not convinced that AVs actually contribute anything to the environment. Congestion, I've already flagged up this idea that actually doesn't work for me. Safety, well, at the moment the jury's out. Okay, we've had 1, possibly 2 deaths, depending on your view of the Tesla incident, associated with autonomous and semi-autonomous vehicles. As I say, 3,200 people a day get killed by conventional vehicles. Not a huge amount of press covers that. I think it's interesting the press has just jumped on the back of the incident that happened the other day. And the final thing, what about the roads? You've probably driven in lane 1 on a motorway in the UK, and you'll notice rutting. That is where large numbers of vehicles drive in the same position on the road. The great thing about that, other roads, is we drive all over the place. And in fact, we wear the roads down fairly evenly because Mrs. Miggins drives over here, I drive over there, the roads get worn down fairly evenly. If we're actually using sensors that force us into the middle, will drive us in the middle of the road, the middle of the lanes, actually the roads are going to get worn down very much quicker. And guess what? That means either more potholes or more roadworks. Or we have to completely redesign our roads so they're like railways with really strong bits down the middle. That's not going to happen. So we actually have to design autonomous vehicles to work on the poor infrastructure that we have in the UK and indeed across the rest of the world. So it's one of these really complex, wicked challenges that actually is fairly typical of autonomous vehicles. Max was pointing out some of the huge computational challenges. We talked about some of the business type challenges. I think this is a really wicked problem. And my thinking at the moment, if we go on to the last slide, we get some drinks fairly soon, is I do think that we will have autonomous vehicles on our roads for very specific purposes, for specific sorts of journeys. I cannot see in the long term, say next 25, 30, 40 years, the vast majority of people using autonomous vehicles. I think the challenge is not just around the technology, but the business model, around safety, around capacity, around the end of vehicle life, around regulation, are very complex, and I do not believe they are easily solvable. Black hat speech over. Thank you very much.
Thank you very much. So
just a quick reminder, just before we go into the panel session, you've got feedback forms. So if you'd like to kindly fill them in, and you won't be let out unless you give us one, just start filling them out, and then we'll go for questions. Please raise your hand so that I can come to you with the microphone.
Okay, good. Thank you very much for a great set of perspectives. So first of all, I want to check how long have you got for the Q&A?
10, 15 minutes, say 15, 20
15 minutes? Okay, very good. So I think we got 15 minutes and we got drinks, so that's good. So let's go. Who wants to have the first question? If you just raise your hand and introduce yourself, and off you go. 1, 2, yes, I'll take the first one, yeah? Then your question, yes? Anybody else? I just want to see who else is out there with any questions. 3, yes?
I'm David Brown. I kind of follow on from Charlie, sort of why are we bothering? The dumb cars, dumb vehicles have been with us, let's say 100 years, that's the lifespan of a dumb car. What's the lifespan are you projecting for automated vehicles?
Okay, so
It's
who is
going to
this
need to
question
be quite
to?
a time to get investment back.
So who is the question to?
Oh, well, I was thinking of Charlie's.
Charlie, yeah.
Well, I was thinking about it.
Thanks, hospital pass there. Don't know. Genuinely don't know. If I was trying to think this through, my question is, or my response would be, why are we focusing on the road when there is drone technology out there that allows us to do things in an environment where actually we don't have pedestrians, it's relatively easy to do stuff, you don't have white lines, you don't have signs. We already have quite a complex environment that's managed quite well in terms of air traffic control. My response is therefore, why are we trying to do the same thing with autonomy when we could do it in the air more easily?
Okay, very good. Yes, sir. Yeah.
Dr. Wafid Karaguli from Brunel University. My question is why all the autonomous cars are big? Is it because of the hardware software? I mean, if you look at the one with the lady in the US, it was 4x4 Volvo. I mean, for God's sake, it's prototype. Why do you have to start with big cars?
Okay, very good question. Who is it directed to? Anyone?
I
Claudio?
mean, the first speaker.
Claudio.
Yeah, Claudio.
Yeah. the question is, why are the autonomous cars big? Why are they physically big in size? Is there any reason?
Even the one he showed in the picture, which is in the challenges standing, it was 4x4.
Yeah, why are they mostly 4x4s? Or is it a coincidence, or is it?
Well, 4x4 was mainly due to the fact that the car was driving through the desert and